This is the first day of factoring, which we're calling Chapter 5. What we're looking for is the initial step, which GCF stands for Greatest Common Factor. This is the first type of factoring that you always look for. So I'm going to kind of put a little star here. Always look for this. Always look for this first. You're going to encounter numerous other factoring patterns, but you're always going to start here. This is always your starting point. I'm going to do the odds, and then we're going to come back and do the evens. In number 1, I look to see what is in common between the 3x and the 3y. Greatest common factor. 3 is made up of a 3 times x. 3y is made up of a 3 times y. And if I look at what is in common, it is a 3. We're going to use reverse distributive property. Reverse distributive property. And I'm going to flip this backwards. So I'm going to put parentheses around this. And I'm going to pull a 3 out, meaning divide a 3 out of both of those. And I'm going to write that as 3 times the quantity x plus y. Now, that's done. That is the fully factored form. If I were to multiply that back in, I would get 3x plus 3y, which is kind of like a little check that I managed to get the original thing back again. Okay, number 3, I told you we're going to skip the odds and we're going to do the evens, then we'll come back and do the odds. So, number 3, 24x and 12, if I look at the greatest common factor between the two of these, 24 is divisible by 12, so that would be 12. I'm not going to write it. All I'm going to do is factor it out. I'm going to put parentheses around these, and I'm going to divide 12 out of both of those. If I divide 12 into 24x, I get 2x. And if I divide it into 12, I get 1. I can't take anything more out of the 2x minus 1, so that is fully factored. That is pulled out, the biggest possible thing I can pull out. Number 5, 19 and 6a. 19's prime. And since 19's prime, it's not going to have anything common in 6a. So actually what I'm going to do is I'm going to say that this polynomial is prime, meaning it can't be factored anymore. So we're going to kind of leave it there. We call it prime. And sometimes I kind of leave it circled as that's a prime one. And if I look at the directions, it says there are 2 prime polynomials. So now there's only 1 left. Number 7, 8 cannot go into 36, but 4 can. So if I take a 4 out of 36t, I get a 9. And if I take a 4 out of 8, I get a 2. And if I look back at what's left, the 9 and the 2, I can't take anything out of that. So this is done. Number 9, if I look at the 9, the 18 and the 9, the biggest possible thing I can take out is a 9. And if I take that out, I'm left with a single m cubed minus 18 divided by 9 is 2m, and then plus 1. Number 11, I can take out a 15, but I can also take out a b, because the smallest power I have, actually the largest power I have is b to the first power, so I just take out a b. And if I divide 15ab by 15b, I'm just left with an a. And if I divide it right over here, I'm left with a 1, so plus 1. Again, look at that, and if I were to multiply it back in, would I get the original thing again? And I would. Number 13, if I look at the 12 and the 27, the greatest common factor that 12 and 27 has is a 3. And then the y is common in both of them too. And then I look and actually pull that out, so I'm left with a 4x plus 9, because 27 divides 3 and y divides y. Oops, let's leave it like that. Number 15. The biggest thing between the 10, the 15, and the 20 is going to be not a 10, but a 5. So if I pull a 5 out, I'm left with a 2z squared minus 15, so not 15, pull the 5 out, divide a 5 out, I get a 3, and divide 5 into 20, and I get 4. And there's no greatest common factor between any of these, so that's done. That's as much as it can go out. Number 17, if I divide an 11 out of each of these, then the biggest power of y I can divide out is not just a y, it's a y squared. That's the greatest power I can take out because it's the smallest power that's present. So if I pull out a y squared, I'm left with 11 takes out of 11, but the y to the fifth, if I pull a y squared out of that, I'm left with a y to the third. Plus, I'm going to keep the pattern going, 3, because I pulled 11. 11 divides into 33 3 times. Y to the fourth becomes y squared, and then minus 4. And that's it. Number 19, if I look at the m cubed, the constants, 9, 12, and 6, 3 comes out. If I pull a 3 out, I'm going to end up with, just kidding, got to look at the m's. M to the third is my largest power. So I'm going to end up with 3m to the second plus 4m, then plus 2. That's what I get when I divide 3m cubed into each of those. Subtracting my powers to get to the m powers. 21, look at the 10 and 15. If I divide 10 and 15 both by 5, then I'm going to look at the a's. I have an a, and then I can divide by a b. Don't go any larger than that because you don't have a b squared or an a squared in both of those. I end up with 2a minus 3b. 23, 6, 12, and 15, I can take out a 3, can't take out a 6. C, my smallest power is a 1, and D, my smallest power is a 1. So I'm going to get, in the first term here, take out a 3 to get 2, divide C in, and I get C squared, and there's no D. Minus, then 4, C divides to get C, then minus 5, D divides, and I get D. That's it. 25, let's try 15 and see if it divides evenly. And then let's try p squared and then q. Because p squared is my power right here, and q is my power right there, and that's going to be the smallest power in each of those. So if I go 390 and divide it by 15, I'm going to get 2, 30, and then 15 goes into 90 6 times. So I end up with 26 p to the second minus 45 divided by 15 is 3 p q, because the q's cancel, and then plus 15 divided by 15 is 1, p squares cancel, and it's q to the second power. And notice how what we have left, I can't take anything more that's common to all three of them. I took taken out the greatest common factor between all of them. We're going to skip over to the back, and I'm going to look at a different kind. And this is factor, and this is a different kind of GCF, but it's still a GCF. Basically, if I look at what's going on, I have a 3 times an x minus 2, and then I have a, I have a minus x times another x minus 2. And it's really, really, really important actually to see that as, I'm going to do this kind of here, it is this minus this. 2 terms, just like before. What's in common to both of them is an x minus 2. And if I pull the x minus 2 out, just like before, I'm going to leave behind an x plus 2. I'm going to leave behind an x plus 2 in front. And if I divide it out of the first one, I'm left with a 3 minus, and then divide it out of the second one, I'm left with an x. And this is the fully factored form. This is a very special kind of factoring that you're going to have to know. And I would refer back to this frequently. I mean that, frequently. You're going to have to come back to these 4 examples a lot, especially when we get to some of the later stuff. Because in number 28, what's in common between the two sides is this entire thing, a y squared plus 3. I wouldn't be able to factor it if it wasn't. And if I put parentheses and pull it out, I pull out a y squared plus 3, and I leave behind a 5y minus, remember there's an invisible 1 right there, so minus 1. Sometimes people ask, why are there not 2 y squared plus 3's? I mean, there's 2 here, why don't I pull 2 of them out? Well, it's for the same reason that when I have 3x plus 3y, and I pull a 3 out, I don't pull out 2 3's, I pull out 1 3. It got duplicated because of the distributive property of multiplication across a distance subtraction. Just like if I were to take this and multiply it in here, and then in here, you would see it twice because of the distributive property. So this is identical to the original one. Now, let's go look at number 29. what's identical is this x minus 2. And if I pull the x minus 2 out in front, I'm going to end up with x minus 2 and then 4x plus 3 left over. Finally, what's in common here is a x minus 5. And if I pull that out in front, I'm left with a y squared plus 6. Okay, 31 is just practice with multiplying and foiling again. We're going to put in descending order, so again, first 6x squared. What I want you to try to practice is the outer and the inner together. So minus 10 plus 3 gives you minus 7x, and then last is minus 5. You should start to be able to do that in one step. 28x squared, then you're going to do the outer and the inner, minus 4 minus 35, which is minus 39x, and then the last you can see is plus 5. Number 33, you should also start to get in the habit of squaring a binomial in one step. The first is going to be this squared, so 25x squared. The outer is 15, and the inner is 15, and 15 plus 15 is 30x. And the last is going to be that squared, 9. First, outer, inner, last on 34. First is going to be that times itself. Outer is going to be this times this, so negative 63, plus another negative 63, because the outer and the inner are the same, so negative 126x. And then finally, the last times itself, negative 9 times negative 9 is positive 81. 35, we just want to make sure we follow the order of operations. So I'm going to keep the 3 outside and square the x plus 1. This will be x squared plus, this is 1x plus 1x, which is 2x. And the last times itself is 1. And then if I distribute the 3 back in, I'm going to get 3x squared plus 6x plus 3. It's worth noting that what we're doing here is not factoring. This is the opposite of factoring. This is multiplying. So just be careful that that is not factoring. I'm going to say not factoring. It's actually already factored. I'm going to give the problem. 36, if I multiply the first two together, I get 8x squared. My outer is 28, and my inner is negative 10. So that's negative 18x. And then last is negative 35. One step. Number 37, first is going to be 9x squared. Outer is positive 6 and inner is negative 6. So they cancel. And then the last is minus 4y squared. This factoring pattern is called a difference of two squares. Or sometimes a difference of two perfect squares, since they do have to be perfect squares. That's what we look like in number 38 too. In fact, it's a difference of two perfect squares, and it comes from conjugates. Well, what are conjugates? Conjugates are binomials. Well, what are binomials? Binomials are polynomials with two terms. Comes from conjugates. Conjugates are binomials that only differ in the middle sign. And that's going to be an important one for you to know. Only differ in the middle sign. So, first, 81x squared. And when you have conjugates, because they differ in only the middle sign, the outer and the inner cancel each other out. I don't have to know what 9 times 25 is. The next one's negative 9 times 25, and they're going to cancel out. And then my last is 25 times 25, which is 625, y to the 4th. Okay, you can stop here, but what I really want you to do is go back up, do, right now, numbers 2 through 26 even. Don't wait for me, and I'm just going to now pause it, do it, and come back. I'm going to do these really quickly. Okay, this is considered part of the notes, so I want you to do these. Don't stop. Go ahead and do these. Just factor them out. Pause video, see what happens. You can zoom ahead if you want to here. If you don't get it, I'm going to give a little bit of explanation and do these kind of again. So number 2, 13's in common, and I get an x minus 1 when I pull a 13 out. Number 4, the x is in common, just a single x. So I have a y left over, and then I have 3 and 1x left over, 3x. Number 6, the only thing I can take out is a 2. and then I'm left with 2x minus 3y. Number 8, I can take out a 7, and I can take out a c, leaving behind 3 plus 5c. Number 10, I can take out a 2 and an x squared, leaving behind a 7 plus an 11xy. Number 12, I can't take out a 3, and I can't take out an a or a b, so this one is prime. That one's done. Number 14, I can at least take out a 2, but I can go bigger than that. I can go 8 and n, leaving behind 3m minus 2. Number 16, I can take out a 3, leaving behind a z squared minus 4z minus 6. 18, I can take out a 2 and a u, leaving behind a 2u squared plus 5u plus a 3. 20, I can take out a p and a q, leaving behind a q squared plus a p squared. 22 can get a little confusing. I can take out an xy, leaving behind an x minus a y, then minus a 1. Don't forget the 1, because that comes from here. Xy divided by itself is 1. It's not 0. 24, I've got 28, 42, and 56. Those are all multiples of 14, because they're multiples of 7 and they're multiples of 2. Biggest power of r is r squared, and biggest power of s is s squared. So I'm going to end up with 2r plus 3s, then minus 4rs. See how it's kind of making your trinomials simpler a little bit? It's not really simplifying, but it is look that way. 26, I can try a 24, but that's not divisible by 64. I think I'm going to just have to take out an 8. And then x to the third, and then y to the second is my biggest power, or smallest power of y. So this is going to give me 6y to the fourth plus 8 x to the third, y to the third, and then minus 3, and that's it.